I'm talking about something which interests me very much, in as much as behind you can see some books. Of course, I won't tell you what they're about. Perhaps you can find out. And if I look directly to my left, I can see shelf after shelf of G.K. Chesterton. And immediately beside me is a lot of stuff by the Inklings. So you can see where I might be coming from. And Chesterton in particular was often accused of being a master of paradox. And I'd like to stand in his shadow so far as I can and begin to explore what seems to me an interesting paradox with regards to evolution and human uniqueness. Now, so far as evolution is concerned, I hope everybody here is comfortable with the idea that we have near ancestors now extinct about 6 million years ago, which were really not much like us and not much like a chimpanzee, but actually our common ancestor. And so it goes on. And in this regard, accepting the reality of evolution and the geological timescale and all those sorts of things, to the very first approximation, the idea has been that evolution is completely open-ended. It is pretty well indeterminate. And as was mentioned a moment ago, my earlier work on the Burgess Shale at a much earlier stage in my career led me to think that, in fact, if, to use Stephen Jay Gould's phrase, we were to rerun the tape of life, then the likelihood of anything like a human evolving is vanishingly remote. And this at first sight seems entirely reasonable, because after all, we have, amongst other things, the randomness we associate with mutations. And more significantly, perhaps, are the so-called mass extinctions, of which there are 5 major mass extinctions and many others. And each one of these, it is claimed, radically reset the ecological agenda. So the likelihood of the history being much the same after the mass extinction is rather small. History is diverted into a new channel. Well, I don't have time, unfortunately, to unpick that in any detail, but my own reading of mass extinctions is actually that they basically accelerate the inevitable. What's going to happen is going to happen. To put it very briefly, the actors who are going to take on the leading role after the mass extinction, like the mammals coexisting with the dinosaurs, are already gearing up for a highly successful existence long, long before the asteroid crashed into the Earth, and so on and so forth. So mass extinctions may actually be, paradoxically, thank you, Chesterton, creative rather than destructive. Destructive over a very nasty weekend, but on the longer term, possibly being more beneficial, if you like. In any case, part of my reading into evolution over the last 20 years has been that, by and large, it's much more predictable than we might have expected. And the reason for thinking this is not rocket science. It's very well known, going back at least to the time of Charles Darwin. And this is a phenomenon we call convergent evolution. And I would probably put on the tape now, because I always give the same example. But if I come very, very close to the screen, I'm looking at you virtually with a camera eye. 2 of them, actually. Now, if I go to the octopus or the squid, which are close relatives of the earthworm, just as you and I are close relatives of the starfish, you'll find that an eye of very similar construction is there. In other words, the camera-like eye has evolved independently in the squid and ourselves. Now, those of you who are biologists will know that already I'm dealing fast and loose with a complex area, not least in terms of some of the genetic machinery associated with eye development. And I don't think it will be necessary, but I'm very happy to unpack that later on if you so wish. But to my reading, the eye of ourselves and a squid is convergent. And this applies basically across the whole of evolution. And it begins to reach some sort of resonance when we then consider what it is to be a human. What are the things which we associate with ourselves, which have evolved convergently? Well, the long and the short is just about everything. Being upright on 2 legs, well, one can think of various examples. The birds are the most obvious. The way they do it is not quite the same, but that's not too important. Another thing, of course, which we sort of sometimes take for granted is our ability to precisely grip things. Now, that's something the apes, by and large, don't do terribly well for good reasons, but there are many other examples of the precision grip. The best one actually is in a frog, as it happens. Then we turn to things like warm-bloodedness, which is probably essential for a steady metabolic rate and the maintenance of other things like large brains. Warm-bloodedness has evolved independently, certainly in the birds and the mammals, but also as far away as the plants. Some plants generate heat. And again, it's not rocket science. The way that this particular phenomena is achieved is due to what are called leaky membranes. And paradoxically, it's actually a very inefficient system. And because it's so inefficient, it generates heat in a nutshell. And then there are other things which I'll come back to in a bit more detail, especially when we look at comparisons with some of the birds. And those are such matters as vocalization, and also large brains, and indeed cognitive achievements and intelligence, and all those sorts of matters. So, of course, there is an enormous range of biological forms, and not everything is trying to evolve into a human. Not everything is, from our perspective, intelligent. Not everybody possesses warm blood, and so on and so forth. And that's not the argument at all. We're not looking at an orthogenesis, but one is standing back and, again, to think of Stephen Jay Gould's rerunning the tape. How likely is it that on a planet like ours, and that begs, of course, a lot of questions, lots of planets, but how many are actually like ours? Big question. Is a human going to evolve? And my take on this has been that actually it's something, well, basically inevitable. Sooner or later, something similar to ourselves will appear. So that's, you may not want to accept that. And of course, there's a variety of views on the importance of convergent evolution. But I think in the last few years, there's been something of a sea change into accepting, at least broadly, a thesis which is by no means mine alone. Jonathan Losos, for instance, recently has written a very nice book exploring various aspects of convergent evolution. But then, here we are, humans are perhaps not so unlikely. Here we are, communicating astonishingly in all sorts of ways, using a technology which even 10 years ago was hardly dreamt of. But more broadly, we have ourselves as being, at first sight, completely different from any animal, completely different. And not for a moment to begin with, as I hinted right at the beginning of this short talk, am I questioning Darwinian continuity. The fossil record of the hominins alone, I think, is sufficient to persuade us that there's, good evidence that a branching process led to all sorts of extinct species, first of Ardipithecus, then Australopithecus, and then Homo. And of those, as it happens, only a single species now is on the planet, Homo sapiens. And if you begin to read into the animal behavior and the way in which we look at the study of animals, as Darwin himself was insistent, differences between ourselves and all other animals must be ones of degree, not of kind. And I mean, how could that be otherwise? I mean, clearly, if there's a genealogy, and you have a moderately intelligent ape 6 million years ago and a hyper-intelligent human today, then those must be joined together in an evolutionary chain. And I don't dispute this for a moment. The problems I begin to read it is that what Thomas Suddendorf, he's actually, I believe, German in origin, but works in Australia, has written a very interesting book, and various other people have contributed to this area in various ways, what he calls the gap. And as you read into the literature, at least as I read it, there's a sort of certain amount of shuffling of feet. And people say, well, yes, there is this difference and that difference, but, in the end, again, to echo Darwin, it's a matter of degree, not kind. Well, I think the way to approach this, which may interest some of you because it has potentially a religious dimension, and I should say very quickly, by the way, we can do an awful lot of finger wagging at this stage because we know, at least I imagine the majority of people I'm addressing here have a belief in God, as indeed I do, and a Christian and all the rest of it. There are many, many other ideologies out there which somehow seem to have a odour of sanctity about them, even though I would regard them as being broadly materialist. And these are ones which are simply unquestioned in the wider world. Whereas at least to a certain extent, the religious perspective is regarded, especially in academia, with a degree of suspicion. Prove me wrong if you'd like. I'd be delighted if that was the case. So the question then is, with regard to the distinctiveness of ourselves and the animals, what is it which actually makes that difference? Now, one could, of course, say that there is very large population sizes. And for instance, one reason to think the Neanderthals died out, it's only one of several, is that actually they had a very limited demography. They were very small population size. And there's some very interesting discussion about their culture in that regard. Correspondingly, people might point out that although the cliche is that we're 99% similar to chimpanzees and 50% similar to bananas and so on and so forth, actually the number of genetic differences between ourselves and the animals, in fact my dog has just walked in, I introduce you if you wish, it's still very significant, and unsurprisingly, because we don't have knuckle walking and we don't make leaf nests when we want to go to bed. We are, clearly not chimpanzees. Those things, though, I think in themselves are not sufficiently persuasive. And in a certain sense, if you so wish, we can go right to the end of the talk. What I'm going to arrive at, so far as I can, is that if you assume the world is simply physical, is simply material, then from my perspective, you will be permanently blinkered. If, however, you are willing to think about the possibility of orthogonal realities, abstractions, mathematics, those sorts of things, and music actually, and poetry, then those are the sorts of things which we have discovered. And why other animals have not, I don't know, but nevertheless, we are entering into completely new worlds. So we are, by terms of derivation, of degree, but in terms of consequence, we are of kind. Now, what I'm now going to say, and you can see, obviously, that this is gloriously unscripted, is to just take you through a number of observations about what animals do and do not do. And in no way is this intended to be as a destructive enterprise. And, oh, Daniel, I should say, by the way, that when you want to draw a halt on this thing, wave your hand and we'll move on to whatever you wish, of course. Sorry, I should say that. Maybe in the next 5 minutes. So the first thing is that in the great majority of cases, of course, and we'll come back to this in a slightly different context, unfortunately, when you're trying to see what the cognitive capacity of an animal might be, and of course there are favorites like chimpanzees and orangutans and New Caledonian crows and all those sorts of things, you can't just go up to them and say, Fred, would you mind doing this? Or could you do that? You've got to train them. And that's perfectly understandable. Of course, in fact, we do this with our children, but I'll come back to that in a different context in a moment. Now, if you read the fine print in the papers which describe this, it's absolutely astonishing how long it typically takes to train the animal. One of my favorite examples, well, actually not really a favorite example, but one of the things is there's an interest in so-called entrainment, the way in which one gets a rhythm, for instance, when you want to dance. And we might get on to whether any animal actually dances or not. But these investigators wanted to discover, using a metronome, tick-tock, 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 whether they could train the rhesus monkey to entrain. In other words, they could change the rhythm and so forth. I'm completely non-musical, but in any case, there are ways you can fiddle around with a metronome. And these investigators spent a whole year trying to train the rhesus monkey entrainment, and they failed. And this tells me something extremely interesting. It tells me nothing interesting about rhesus monkeys, which are fine so far as they go. It tells you something about those investigators. What other investigator would bother to spend a year trying to entrain rhesus monkeys? And again, we find that, for instance, in some experiments where they were trying to teach some starlings something, 50,000 trials. And not only that, but again, if you go into the really small print, you typically find that actually they might start with a cohort of 15 because these animals are expensive to maintain and so forth, and several drop out. And then they have a more advanced experiment and several more have dropped out. So usually it's a smaller number which actually go to the final stage. And that's all right. But then the next problem, of course, is that let us say they can do one party trick. You then ask them to do another party trick. So Fred the chimpanzee is a genius at some particular thing. You ask him to do something else which we would regard as cognitively equivalent, and perhaps it isn't, but we regard it as such, they're hopeless. So what's happening here is a sense that they're not going to get things terribly easily. Now, this is exactly a point where a picture would say, save me 5 minutes of explanation. But amongst the many very clever experiments which have been done in the last 10, 15 years is one which revolves, and some of you I'm sure will be familiar with it, the so-called Aesop's fable, whereby in Aesop's fable, the thirsty crow, unable to get the water from the jug, drops stones into the jug, so raising the level of the water. Here comes Archimedes, that's another story. And eventually enough stones are dropped in so that so the crow can drink. So what you can do in the laboratory is set up a similar system, and you can test them in all sorts of ways. And sure enough, with not so much training, crows, which are notoriously intelligent, along with the parrots and the hornbills, can drop stones into the tube to raise the level of water. And that in itself is not terribly exciting, but of course there's a piece of chow, as I believe you Americans call it, on the water, which then comes within reach of the beak of the bird. And this is all very well, and you can do all sorts of clever things, like you can make stones which float, you can fill the tube with sawdust, you can do lots of things to try and trick them. But what's apparent is that this at first sight is a really dramatic illustration of animal cognitive skills. But then what you start to do is something rather sneaky. And for instance, you have a U tube where they can't see the U at the bottom. And correspondingly, you might even have 3 tubes. And this is where you can begin to test cause and effect. Can the crow actually work out that by doing something here, there'll be a consequence somewhere else? And the short answer is no, they can't. And in fact, a whole batch of recent experiments has very much confirmed this conclusion, that they are unable to work in a world made of cause and effect. They just don't get it. They can't join the dots. Ultimately, and if there's a sort of second major conclusion which would come right at the end of a talk like this, the whole thing revolves around, and this is not an area which is accepted by everybody by any means, but to the very first approximation, it is to ask whether you can look inside the mind of another individual. Can you understand that person's motivations? Now, that other person might well be an actor, or a comic, or a mimic, or may in fact be a criminal. Any one of these are possible. You know, they might well be disguising what you'd like to know. But even so, on a day-to-day basis, we can make reasonable assumptions about what other people are thinking, not only about themselves, but also what they think about us. And this is broadly under the so-called theory of mind. And the general sense has been that the more cognitively advanced animals do indeed have some sort of theory of mind. They have some sort of idea. Well, it would take forever to begin to unpack these various sorts of questions as to whether, in fact, apparently knockdown experiments, some were actually only a couple of years ago, where you hide something and then it reappears somewhere else, and you have to work out whether the animal itself can judge what is actually going on. But again and again, we find that apparently knockdown demonstrations of theory of mind ultimately turn out not to give you the evidence which you actually require. So I'll have to look at my notes here. Yes, so with this, the question then of animals' cognitive capacities can just turn into a fairly long catalogue of things which at first sight look convincing, but at second examination are not. And I'll just give you a couple of examples before I talk about language. Now, the thing which people say, you know, sometimes when you're talking about this, you say, you know, animals can't teach. And they're generally sort of, well, you can't say that. Of course, you know, I've seen cats teach their kittens how to hunt mice and so forth. What we have no doubt about, necessarily, because otherwise the animal experiments wouldn't work either, is that animals certainly learn. But there is no example whereby the animal actually instructs the tutee what to do. And this is actually, I think, related entirely to the theory of mind. They do not understand that the individual beside them is a pupil, which might be quite bright or might be quite dense. It might be quite sort of agile, or it might be quite clumsy. And we can quite quickly assess with other people, what the best way of getting the information across. And one example, which I always find very interesting, I'll come back to that in a related context in a moment, is to do with tool development. And in some parts of Africa, the chimpanzees, the females almost exclusively, the boys go hunting. Are we allowed to say that? I don't know. I've just said it. Never mind. Let's go on with it. They crack open nuts with stones. They can use trunks of wood and various other things. And they smash open these stones, and they have nutritious kernels, and that's all to the good. And in a convergent way, the same trick has been learned by the New World monkeys, the capuchins in Brazil and places like that. So the point there is that the young sit beside the mother, and over a number of years, they slowly learn how to break open a nut themselves, holding a stone. But at no point does a mother ever turn to the infant chimpanzee and say, no, you do it this way, hold the thing, don't do it like that. And indeed, some adult chimpanzees actually use wedges of stones to anchor the nut. So again, it's not that they're being particularly stupid, but what they can't do is convey that information. And another famous example, which in a certain sense is the one which I think is so convincing, involves the meerkats. Those adorable creatures, yes? And they, amongst other things, in the Kalahari, enjoy eating scorpions. Now, clearly, if you're going to introduce your young meerkat pups to a scorpion breakfast, you're going to have to be pretty careful. It's not the breakfast you and I know. So what happens is that the adults initially kill the scorpion so that they familiarize the young before they eat it. Then they defang the scorpion when the pup is slightly older. And ultimately, when the pup is, pretty competent, then they are, able to deal with the live scorpion and not be stung. And this at first sight seems to be a very convincing example that information being transferred to the benefit of the pup. No, it's all dependent on the sound, the calls which the pup makes. So if the wily investigator substitutes a false sound, which is that of a more mature pup, then the parent, the mother typically, will be deceived into thinking that the pup is more experienced than it actually is. It doesn't actually look around and say, "Oh, crike, that's Andrew, age 4. Can't let him drive a car." And I know in America you probably drive it about the 8 or 9, I guess. Is it younger than that, Dan? You must tell me sometime. So, in my view, there is no evidence of pedagogy, and this is actually related again to this ability to convey the information. And so that's one aspect about that. Another thing which could come in at almost any point, and please, again, I must keep on emphasizing, I'm not trying to be destructive here. I'm not saying, these animals are stupid, far from it. For what they need to do, they do it extraordinarily well. And in many contexts, I think of my dog's smell, it's much, much better than mine. They're skilled at what they need to do, but they're generally one-trick ponies. And a related thing in terms of self-awareness is what's known as mirror self-recognition. Now, mirrors, as we know, are actually, and as Alice found out in Alice in Wonderland and Through the Looking Glass, are actually very peculiar things indeed. But a whole lot of experiments being done on whether, especially putting marks which are invisible to the animal unless it looks into the mirror. And for a number of years, it really was looking as if, again, it's a bit like when you cut yourself, when us chaps cut ourselves shaving, saying, God, I can't go out looking like that, put yourself up, and this sort of business. It did seem that some species, not all of them, seem to be capable of so-called mirror self-recognition. But recently I learned that, interestingly, these examples of mirror self-recognition, first of all, are quite sporadic in terms of the species which can show them. So amongst the corvids, that's a crow group. Some seem to be quite good at it, but most of them are not. But on the other hand, practically without exception, the animals which, of course, understandably are available for experiments and training are those in captivity. And one of the interesting things about this is that it turns out that animals which are what are known as enculturated, that is that they sometimes, in the case of chimpanzees, are basically brought up as a member of the family, but are in daily contact with humans, are simply brighter and more intelligent than their cousins in the jungle or in the woods or wherever they might, or the prairie, wherever they might be. And this is not in itself particularly surprising because, of course, we know that the brain is malleable. Clearly, the animal is open to stimuli. And if you spend 25 years watching everybody else do something, it's not terribly surprising that you will show better abilities. And then when you start to go and look at the various attempts to teach animals the rudiments of mathematics or speech or anything else like that, it turns out actually that they are enculturated ones. So when you go out into the wild, you do not see an animal looking Narcissus-like into the pool, admiring its own reflection. It has no need to. It's no part of its world. So that's an additional problem with sort of teasing apart what exactly it is which makes us different. In as much as that, even though those animals which are enculturated are indeed generally cognitively superior, they still don't show the least sign of, for example, speaking or anything else like that. So a few more examples, not to depress you, but again, to emphasize this difference. Tool making. Well, it turns out, in fact, that first of all, tool making is very sporadic amongst the animals, and there's no obvious correlation with intelligence. Some fairly, I wouldn't want to use the word thick, but, less cognitively impressive birds actually can use tools, like Darwin's finches in the Galapagos. But the really crucial observation is, first of all, so far as there is a correlation with tool making, it is with respect to sociality. There we are. So that's an important feature. But more importantly, no animal ever uses one tool to make another tool. Some chimpanzees will indeed use one type of stick to access the termite nest and another type of stick to actually get the termites out. Other chimpanzees will indeed make a brush-like appendage to the stick to capture more termites. But the fact that they are never able to use one tool to make another tool means that they will never ever have a technology. They will not be able to build on something where two parts of a tool make a machine. And then, as we know perfectly well, often the ultimate machine you make may depend on different combinations of tools, but is actually doing something totally different from what the inventor originally expected. So this too suggests that, as with the Aesop's fable, they're not able to join the dots in terms of what they need to do, they do perfectly well. But in comparison to ourselves, where we really have this ability to see behind things so that we actually understand the process of the construction. What in the end does it all boil down to? Well, in a book which I hope will be published in the not too distant future, and I'm sorry I can't even show you a picture of that, even though it's unpublished, but I sort of jotted down all the different sorts of things which make us human, and they include such things, obviously, as cumulative culture, but they'd also include things like religion and warfare, but perhaps most importantly, telling stories. And that actually will perhaps segue into what I want to conclude saying in a few minutes. But the point about this is you can make a sort of, it's almost like a Kabbalah, actually. It's a sort of network of interconnected phenomena which define our humanness. And the interesting thing about this, from my reading of it, is that, first of all, it's almost impossible to say, oh, well, we started with that first and everything else led from it. And correspondingly, we can take away some aspect of it. For instance, when people have had strokes and are aphasic, and yet you can show it's a fairly distressing set of experiments, but you can still show that their theory of mind is still there. And that, of course, begs questions, which I might come back to in just a moment. So the point about this is that one has this whole sort of network of things which allows us to be human, which are interdependent on each other, and in certain seem to be almost sort of self-generated. And so far as there is something which is genuinely central, and this again is a cliche almost, it's language. People say, well, that's quite all right, because I could probably get a demonstration bark from my dog if I tried. Animals vocalize, and indeed there's a viewpoint that animal vocalizations are, in some cases, proto-language. They are the beginnings of words. And to give just a couple of examples to show you why I'm not persuaded by this, and I should say, of course, that this is very much being based on other people's work. To begin with, we take the famous example of the vervet monkey. Now, the vervet monkeys famously in East Africa have these 3 calls, alarm calls, one to identify leopards, one to identify snakes, and one to identify eagles. So they're obviously in very different sort of contexts, because if you're going to be attacked by an eagle, then a snake is of no interest to you at all. And indeed, in that particular group, those calls are associated with those threats. The problem is twofold. First of all, that the calls are also used in other contexts. Now, yes, it is true that we can use words in different sorts of ways, but there's no evidence to suggest that they're actually employing a meaning which can be transferred from snake to something else like that. It's still a call. It is not a word. And correspondingly, you go to other groups of vervet monkeys in other parts of Africa, and yes, they have calls, but they're not the same sort of calls. And my best example, and I know these days because of all the political correctness, you have to be so, well, I'm of an age where I couldn't care less, but that's another story. There's another group of monkeys called the Campbell's monkeys. And what happens there is, and this will come as no surprise, I think, to a few people, and my wife, I believe, is an earshot, so they say, are you there, dear? Is that the female monkeys are indeed very vocal. They're chattering away the whole time, a continuous racket and noise. And the reason for this is again, ecological, that they are principally in charge of the young monkeys. So you've got to spend a lot of time communicating with them. What about the men, the males? Oh, no, very different. Hardly a word all day. Just a handful, now and again, very, very occasionally, And that's that. And you sort of think, well, if this Campbell's monkey is going to have a language, I mean, it's a matter of cliche, but the difference between how men and women communicate on certain occasions. But even so, you would expect them to have a good deal in common. So, fine and large, that's a politically incorrect statement about Campbell's monkeys. I probably have something to say. They'll probably be in touch with me. The one which I think is particularly interesting is birdsong, because birdsong at first is by far the most convincing analogue of language. And it's also useful because it is clearly convergent. The common ancestor of the birds with the dinosaurs versus ours with another group of reptiles is satisfactorily remote. And again, at first sight, it does seem to be that birds have something we could regard as being akin to language. The young, for example, and here I'm talking about birds which are taught song, not those which have innate. So the songbirds and the parrots and the hummingbirds, again, all convergent, is that they go through the so-called babbling phase, where they experiment with the noises they make in the same way as those of us who've had the pleasure of having young children can actually, hear this babbling as they begin to crystallize language. And correspondingly, if you look at the bird's song, there are, if you like, phrases, and people sometimes talk about a syntax, that there is some sort of construction in that, and corresponding other people talk about a semantics, in other words, that there are something which look like words there. Well, this is, I think, a very imperfect analogy indeed, and for a number of reasons. The first of all is that this line of communication, which does look something like a sentence, is very, very shallow. It doesn't show anything which we would really call recursion. There's no evidence to suggest that they can rearrange those sounds so that they can put one meaning inside another meaning inside another meaning. And of course, that in its own way is entirely non-trivial, not only because, of course, it allows us to conceive of complex things, but also because it allows us to tell jokes and things like that. And that's another thing. Animals don't tell jokes. They can be very amusing, but they don't tell jokes. And the second thing about the bird song is that they don't ever export this set of sounds to some context unconnected to what we associate with birdsong, which the very first approximation is very largely to do with territorial defense and sexual attraction. So there's nothing wrong with birdsong. To our ears, it's often extremely beautiful. It is indeed extremely complex in certain cases, but it is not a language. And I'm not a linguist of any description. Please, nobody ask me a question about Chomsky. I wouldn't even know how to start in this sort of area. But it seems to me that if you want to make language the central condition of the human, then if we understood how to articulate things, then one would begin to understand how we manage to articulate ourselves. Now, I don't want to go off at a great tangent at this, but nobody needs to be reminded of the opening words of St. John's Gospel, or indeed the primacy of the word. This thing where one conveys things of almost infinite depth. One could go on, and I'll come to a halt quite soon, Daniel, if that's okay. If that, he nods vigorously. Yes, please. Yeah, please finish as quickly as you can. Would you mind? As I was trying to hint right at the beginning, when we think about humans and how they are different from animals, one thinks of our capacity to deal with abstractions. And fortunately, I'm not qualified to talk about this, but the example, because of being lucky enough to work in Cambridge, and I'm sure many of you will have similar colleagues, to anybody who's involved with mathematics. And many of you will know the famous essay by Jean Vigna, The Unreasonable Effectiveness of Mathematics. And that and similar essays just sort of say, I wish I could persuade my academic colleagues how absolutely extraordinary it is that these concepts work. Where do they come from? And, you know, we can go down there. One can think of the famous work of Ramanujan and people like that, and that's another very interesting bag of stories there. But certainly any attempts to introduce even the elements of mathematics to trained chimpanzees are dismally slow and pretty unconvincing. And once again, there's a Darwinian predecessor in the form of something known as numerosity. I'll happily unpack that if there's any interest, but this is an ability to judge approximations of relative numbers. And the normal leitmotif of most Darwinian biologists is numerosity, this ability to deal with numerical magnitudes and so forth, is the precursor of mathematics. Well, I don't think it is at all. I don't think so. You know, there's something like a complex number or a logarithm or anything like that. These are things which are, to many people's view, actually discovered. Some people suggest they're invented. The arguments can go either sort of way. And that, in the same way as language, and I think also human music, again, I'm entirely unqualified, is that one can find what appears to be an echo in birdsong and so forth. But our music is not the same at all. It's something which, again, is transcendent. It is something which is taking us off into completely new worlds. So, in a sense, to try and conclude, if we are willing to accept that there are transcendental realities, I'm not, again, trying to talk in a philosophical way or Kant or anything like that, I'm completely out of my depth here. If one is, particularly from a Christian perspective, and of course there are many other traditions which have their own insights into this area, we don't have a monopoly in this at all, then one is entirely familiar with the ability that there are things, as we say tomorrow in the creed, things seen and unseen. And these things which are unseen aren't, they might be technically invisible, but they're not unknown, and they are to a certain extent familiar. So then, of course, you can see evolution, at least ourselves, as being much more like an exploration, that we're something where we've been invited into this completely new world. Now, clearly the temptation here is to say, well, aren't we lucky? All those animals around us are unintelligent, dumb brutes. Not at all. Absolutely the reverse. I don't know, in no way do I want to say, well, no, because we're strutting around. We have a sort of suzerainty which allows us to trash things. We might be quite good at that. Very much the reverse. We have the responsibility of knowing these things which other animals simply do not know. So it's actually part of our gift, and it's one which we've been asked to be responsible about. And the general idea is that sooner rather than later, certainly so far as my age is concerned, one will be asked to give an account. And I'm afraid in my case, I won't go into the details. It's going to be pretty grim reading. So the idea here is to try and not shift the perspective so much, but just to argue that we're dealing with incomplete business. And in particular, with regard to evolution, in its own way, it gets a certain distance. But if we then refuse to engage in any sort of metaphysics, then one's going to end up in continuous disappointment. And so that's why I think, the apparent uniqueness of humans is so absolutely fascinating. It's genuinely there. It's not simply our imagination. So Daniel, with your consent, if that's all right, I can ramble on for another few minutes, but perhaps this would be a good time to draw a line, because I've been talking for too long in any case, if that's okay.
That sounds good. Thank you very much. Yeah. So at this point, we'll open up for questions. If you're on Zoom, if you want to type them into the chat, and if you're in the room here, you'll have to walk up here for questions. But I'll just start with one while people are doing that. So you talk about the interest about animals when they're enculturated, they have different behaviors and so forth. So what, you hear about like Neanderthals and what they were capable of. And how much do you think some of that is their enculturation, being exposed to modern humans and interacting with them, or you're right, or is it something that's unique to them in terms of their level of learning, rationality? What is your thoughts on that? And I'd love to hear that.
Well, thank you for the question. Again, I'm very much basing my thoughts on other people's work. To the first approximation, it seems more and more likely that the things which we regard as being culturally significant amongst the Neanderthals were arrived at independently. It's difficult, because, as you know, the majority of people, the few I can see on the screen, but the majority of people, of course, will have about 3 or 4% Neanderthal DNA in them any case. And don't worry, if you don't have it, you're not excluded. Everybody's got some archaic DNA, so in no sense should anybody feel left out of this game. All humans have some sort of archaic DNA in them. But one of the examples I found sort of particularly interesting was the examples from former Yugoslavia, where you've got bird bones which have got incisions in them, which were evidently to flense the big flight feathers. And these are eagles and so forth, I'm told are pretty inedible. And the idea is that they, in the same way as feathers are used very widely in many societies, in the Polynesians, in the Great Plain Indians, and so on and so forth, then this is an indication of some symbolism that they're conveying to the other people. What I came across literally a couple of days ago, and this is sort of, there's something about Neanderthals which doesn't quite get there, or so it seems. There's almost no doubt, in fact, there's a very elegant set of experiments to show not only were they capable of speech, it'd be really odd if they didn't have language, but even in fact that some of the consonants they use are exactly the ones you need when you're talking close up to somebody you're having a conversation with. But maybe, as I hinted right at the beginning of the talk, they seem to have been in very small populations. And there is an interesting suggestion that in contrast to us, which are famously hyper-cooperative, their cultures were effectively, if you like, individual. They never came together as a collective. And that sort of somehow seems sort of right. They're good at all this sort of stuff. And not to go on too quickly with this sort of particular one, was the business of, if you look at the middens with the bones and so forth, we know that not all Neanderthals, but quite a few lived in tundra-like environments where it's extremely cold. And there's nothing better than a fur from certain animals like stoats and the like, which provide a lining, especially around the face and the hands, which actually help to intercept the cold air. And you get this sort of, if you've ever seen an Inuit, it's got all this frost around here. And the reason that it's got all this fur, which helps to protect the face from when you get a cold. And if you look at Homo sapiens, they're accessing these animals for presumably that reason, but the Neanderthals don't. So there's something they don't seem to quite get there. But having said all that, and in fact, I came across a paper which I only skimmed and knew Blackfriars, with the argument, I'm not a theologian, that if we have Neanderthal DNA, then somehow, as Neanderthals themselves, they must be part of the scheme of human redemption. But that's another story.
Thanks. We have a question here.
Okay. Dr. Morris, it's a real privilege to speak with you. I've been a fan of your work for years, and I apologize. I'm going to do something that usually irritates me when I'm the speaker. I'm going to ask a question that's not precisely germane to your talk, but is related to your previous work and all your research on the Cambrian explosion and so on. So as we know, Darwin realized that the Cambrian explosion was a challenge to his theory of gradualism, and he explained it as an artifact of the fossil record, of the incompleteness of the fossil record. And so just briefly, what is your position on that? Do you think the Cambrian explosion is a real event in history, or is it an illusion created by the imperfection of the fossil record? And if it is a real event, how is it reconcilable with innumerable successive slight changes that are necessary for Darwinism?
Well, thank you very much for the question. I mean, I'll ask Daniel to allocate me another 4 hours. Thank you, Daniel. That's very helpful. First of all, I've done a little bit of work on the Cambrian recently, but not very much. So I'm not completely up to speed with all the things which my colleagues are working on. But in brief, it's a real event. Yes, it's there. And Darwin, in a certain sense, was right to be puzzled by it. The difference, of course, is that we know a considerably greater amount. And there are really two aspects to it without drawing out my reply too much. The first is it's increasingly clear that the preceding faunas, which are known as the Ediacaran faunas, which are basically, if those of you in the trade will know, as post-snowball, those are part of the Cambrian story. That's pretty clear. In fact, some work which I was going to do with the Chinese until the whole world fell apart, would have been indeed a very interesting exploration. But I think that's going to be some time before it's picked up again. Then the second thing, of course, is with regard to the evolution of the Earth, generally speaking. And there have been lots and lots of toing and froing and so forth about changes in the atmosphere and changes in the oceans and so forth. But it's fairly clear that the ancestry of the animals per se goes back really quite a long way. But more importantly, in a way, is first of all, some things probably aren't possible till we have quite significant changes in the ocean states, especially the degree of stratification. And that is something which, if you like, is sort of, my friend Nick Butterfield wouldn't quite agree with, but it's slightly out of the hands of the animals themselves. But otherwise, and this is not quite answering the question, but I say touche here because I don't mind being asked questions which I wasn't talking about, and vice versa, is that, of course, we now know, and this is generally true of evolution, that a very significant proportion of what you need to make something interestingly complex has evolved long, long before that complexity itself has emerged. And the reason for this, of course, is that these things are co-opted into their new function. So if we look at the predecessors of the animals, approximately, again, I apologize for those who are very familiar with this area, the so-called choanoflagellates, it's now clear that a good deal of their cellular machinery, including parts which are necessary for the nervous system, these are single-celled organisms by and large, has already evolved. So there's a great deal of the heavy lifting has been done much earlier. Changes in ocean state are necessary before you can have large animals. And correspondingly, the Cambrian explosion itself is actually, if you like, more dilated than we first thought.
All right, thanks. We have a question from somebody on the Zoom call. He asks, how do you assess the case or the position that human morality has its base in animals and primates? So do you accept the claim that the sort of like Darwin had, the fundamental rudiments of human morality are there in the animals and sort of evolved? Do you see that as a discontinuity as well?
Well, probably you should invite Francis to give your next lecture. I've met him once, a very entertaining, a very interesting man indeed. And indeed, if you talk to the great majority of the primatologists, they will pretty well insist that at least the rudiments of moral behavior and altruism are indeed expressed in the animals. Well, so far as I read rather than research, not for a moment do I think that the animals we're interested in are not conscious. Of course they are. Not for a moment do I think that they don't have emotions. Of course they do. But I think, again, it's all to do with this theory of mind, of actually putting yourself into the shoes of the other. Now, I understand that many primatologists would argue that this theory of mind is exactly something which they do possess, but I think overall the evidence is weak at best for this. And so there's a whole area to do with so-called prosociality, the sort of first beginnings of understanding what's going on between each other. But there are various papers which I think of, one of the only advantage of this technology we have is if you want to find out what somebody's published on something subsequent to the original paper, I can find out in 30 seconds. It's absolutely wonderful. And these papers, which I've been just checking up in the last few weeks, is that it's pretty clear that animals, they can lose their temper, but they don't have any concept of revenge. They don't have any concept of spite. And I think the difference would be that, well, in a certain sense, the interesting analog, and this is fair, I wouldn't say it's disturbing, but it's to do with these extraordinary cases of feral children, the boy of Cambrian in particular, but a number of others where children, for whatever reason, somehow survived in the wild. And they are indeed basically very close to being animals. They're not actually in any sense human because they have not been enculturated. As I mentioned already, of course, the animals are enculturated, but they somehow just can't make that break. But again, thinking of Chesterton in particular, if you remember one of his stories where, he said, I could probably find it quite quickly, but his famous story, whatever sort of remote planet you might be on, you can be fairly sure that you will find somewhere a sign saying, "Thou shalt not steal," And if you are subscribing to the idea that our morality and our ethics, however much we may fail in them, are ones which are real and are ones which are not imposed on us, but ones which we are well advised to follow for our own good, then if those things are also transcendental, then if a chimpanzee or a crow had some intuition of it, I don't think there's much evidence of that. I wouldn't be surprised, but my basis would be that these two are things which we discover. And again, I'm not a theologian, but my very limited reading of the Old Testament and the New Testament, and especially, that wonderful story we were reminded of the other day, of the Emmaus story, where these chaps are wandering along and chatting away and a character joins them and so forth. And then it suddenly twigs on them. And clearly, I say clearly, because of the fascination who those people actually were, it's fairly clear, suddenly everything clicked together, and clearly Jesus had spent probably several hours explaining to these people, that's what what we call the Old Testament says at that point. Didn't you see that? So it's a way in which you build on that information. So that would be my take on that.
Hi. So I have a question about the I think you call it the Aesop fable experiment with crows. When I was a boy, I was very impressed with what I thought was highly intelligent problem solving by my dog. He was trying to get at someone who was out the front door. The front door, of course, was locked, closed, and he wanted to get at this person. And then suddenly it was as if he had an idea, and he ran to the back of the house, out the back door and around the house. And I thought, that's very clever problem solving. And then later it occurred to me, but that's the kind of problem that they face in the wild all the time. They're either trying to get at a prey or get away from a predator, and they will try different means of access or escape. And so that's a sort of an algorithm that might have evolved in them for situations they face in the wild. And I wonder if it might be true with the crows, that very clever problem solving of dropping the stones in might be something, an algorithm that's a situation they might actually face all the time in the wild, and maybe there was simply an algorithm that developed for solving it. So it wasn't a creative idea that they had.
Sure. Thank you. No, thank you very much. That's a helpful reminder for me. First of all, because for reasons best known to themselves, again, I'm told one of the things some birds, but especially crows, like to do in their day-to-day life is hop around with stones in their beaks. And this is not, they're not looking for pitchers full of water or gin, perhaps. Also related to that is some of you would have seen this incredible set of experiments involving a New Caledonian crow called Betty. Now, unfortunately, Betty, who lived in Oxford, is no longer with us. They had a funeral in St. Giles. It was attended by thousands, of course. But Betty was given a straight piece of wire and a test tube, and at the bottom of the test tube was a bucket with food in. And the video is very telling because Betty fiddles around, pushing the wire in, trying to retrieve the bucket. Total failure, of course. And then you see the bird hop against the side of the tray and push the wire into a hook. Lowers the hook, retrieves the bucket, and there's wild applause. Yeah, and it looks like a really joining the dots thing. The problem again is that sort of hook making is part of their innate behavior. And indeed, in the New Caledonian crows as a whole, it's fairly clear, and this may apply to us as well, mind you, that actually some parts of their tool making are actually innate as well. So yes, indeed. And everybody has stories about hyper-intelligent dogs. My favorite one is our previous, we've got a spaniel roaming around here, but our previous Labrador is whenever somebody knocked on the door, it would go berserk. They're quite right too. And so one time it was outside the house rather than inside the house, and the door knocked, and what does the dog do? What does the dog do? Goes berserk, because it associates the sound. I don't think it's got a clue as to what side of the door matters. That's not its job. Its job is to make a racket whenever the door knocker goes. So yeah, I think that's, those are the sorts of examples. As I say, I mean, the thing about dogs, I mean, there's a bag of stories there. I mean, first of all, remember that we are basically symbiotic with them. And also they show lots of things which chimpanzees are absolutely useless at, like gesture and those sorts of things. And our ability to train them is absolutely phenomenal. But if you don't train them, they're basically typically at sea. There's some interesting experiments where people faked heart attacks or had a wardrobe drop on top of them, and they want to see whether the dog would rush off for help. Well, of course it didn't. Nothing of the sort. But if you train the dog to bring a bottle of brandy halfway up the Alps to save somebody in the snowdrift, you're in business.
Great. We have, if you have time for one more question here. So this is a question about extraterrestrials and Convergent.
Oh.
So this is a little plug for the Society of Catholic Scientists meeting coming up here that you'll be talking at. So somebody from Zoom had asked, given your thoughts on convergence, what do you think that extraterrestrials might look like?
As we say in my country, thank you. Yes, convergence would also suggest that Earth-like planets should ultimately, in many cases, produce humans. And I would still adhere to that idea in principle. Unless something's happened in the last hour, to the best of my knowledge, the Fermi paradox, as it's called, the famous "where are they?" holds. There's no evidence at all of anything in terms of extraterrestrials. And one can unpack this in lots of different sorts of ways. And we could, if you wanted to be seriously annoyed, we could go off into the topic of UFOs. We can't talk about them, of course, because they don't exist. Well, they do exist, but of course I have no idea what they are. But whatever they are, they're not, in my view, they're not extraterrestrials. But one of the things which has become clear is not only the superabundance of planets and also the likelihood of many Earth-like planets, of which some will be, from our perspective, habitable, and we should not be too narrow-minded here. But the really crucial observation made by Charlie Lineweaver and some others the last few years is that it's very, well, in fact, the first planets seem, I believe, I'm not completely up to speed here, formed about 12 billion years ago. So about 1.5 billion years from the Big Bang. That's, okay, we've got planets. They may not have been habitable, but that's another story. Solar systems, which we would be familiar with, are certainly forming at least 4 to 5 billion years before our solar system. We are relatively late. Now, if you subscribe to the idea that there are habitable planets and that they have evolutionary processes and a convergence is a likelihood, then in principle, if we have the emergence of a technology, they will have a head start of maybe 2 billion years, maybe 3 billion years. So the long and the short of it is we shouldn't be here, because they would have arrived in the Burgess Shale times in the Cambrian. And if I know anything about these extraterrestrials, they're a bit like me. They're gourmets, and they particularly like a glass of Chablis. Very nice too. Well, maybe even a Montagny. Those of you like white, I see some nodding round the up. Now they all are nodding furiously. Yep. You stick to the French wines, my boy. The Californian ones are good, but no, Montagny for us all. And so they're there, and they think, well, we're not meant to do this, of course, and we've got our own supplies on the spaceship. But let's see if there's anything in the ocean which is edible. And they're swimming around in the shallows. There are these little fish-like creature which we call Pikaia. And the next thing we know is we, the ancestors, Pikaia being the ancestors of the humans. Here I simplify enormously. We're in a line like a line of anchovies on a piece of toast. We shouldn't be here. The planet would have been taken over, and, who knows, in the Cambrian, they probably wouldn't have been too concerned, I'm afraid. So there's something about the Fermi paradox which doesn't add up big time. And I wrote a paper, which I think is the least referenced paper I've ever written, which I'm very proud of course. And the subtitle is 3 Explanations for Extraterrestrials. How does it go? Sensible, that is, we haven't yet found them. Unlikely, well, we really are alone, but, you know, it's possible. Or mad. And it's the final one, mad, which is actually the correct one. It is that the universe we live in is not the universe which the materialists identify. And if one again subscribes to orthogonal realities, then I think the extraterrestrials are there, in a manner of speaking, but they're not at all recognizable. So no point looking on planets. You've got to look somewhere else.